In Module 3, we will address the fundamentals of linked data and accessing linked data over HTTP. So according to the definition found in DBpedia, linked data is a method of publishing structured data so that it can be interlinked and become more useful through semantic queries. It builds upon standard web technologies such as HTTP, RDF, and URIs, but rather than using them to serve web pages for human readers, it extends these technologies to share information in a way that can be read automatically by computers. So if software understands what URIs will return RDF for a given data set, that URI can be specified along with some other preferences so that instead of returning web pages, the server will return RDF. Hopefully this will make it a little bit more clear. Linked data implementations typically have a URI for a web page and a whole separate URI for the entity that the page is actually about. So for example, here in DBpedia's URI pattern, we see a page URI for the concept of linked data and a separate resource URI for the concept of linked data itself. So that middle pattern is really important when telling tools that you want to either see a page or a more linked data RDF ready application can use this other URI. So when software requests information from a server using HTTP, it declares what its media type preferences are with an accept field in that request. Because web browsers cater to presenting human readable documents, they focus on accepting media types designed for web pages. So text HTML or application XHTML plus XML. If a server is given an entity URI, so think the resource URI for DBpedia URIs, from a browser, the server often redirects from the linked data entity to the web equivalent. So take a minute here, pause this video, and try adding that linked data or the resource linked data URI in your browser and hitting enter and see what happens. Most browsers will redirect you to the page URI. As you may have guessed, one of the first steps needed to access data from a known data set is to understand the RDF entity URI pattern for that data. The good news is the PCC, Program for Cooperative Cataloging, URIs, and MARC task group has gone through the trouble of figuring this out for many of the data sets that libraries use. Please note that this document may need some updating, or the link that we provide here in the slide may need updating depending on the data set you might be interested in. While in theory, cool URIs don't change in the real world, there are many reasons these changes happen to the URI. Stepping out from the library perspective, another place to go to find out and discover data sets or linked data sets on the web is the Linked Data Cloud. You've probably seen this graphic or one similar. As of May 2020, this cloud contains roughly 1,255 data sets. A little bit more background: linked data publishers can register their data sets for the cloud, assuming that they follow best practices and the selection criteria outlined by the Linked Open Data Cloud maintainers. From the UI of the site, you can filter by discipline and subclouds. So if there was a particular disciplinary area that you wanted to see if there were existing data sets on the Linked Open Data Cloud, you can filter down by those. For Module 3, familiarize yourself with the Formulating and Notating URIs document provided by the PCC. Try to better understand the URI patterns for different data sets. I also challenge you to familiarize yourself with the Linked Open Data Cloud, explore the different filters, and see if there's any data sets there just based on the description that you think would be useful in the library context. Feel free to share your responses or related questions with me via email, the workshop Slack channel, or during the workshop office hours.